Okay, next we're going to speak about private VLANs. So let's see what are private VLANs. Pretty much the name also is self-explanatory a bit. So by default in a VLAN, all hosts can directly communicate at layer 2. So we have 10 hosts in a VLAN. As long as ARP works to resolve their IP to MAC bindings, they can directly communicate in the same VLAN without any problem. So private VLANs is aimed to control which hosts can communicate directly at layer 2 within a VLAN. So scope is achieved by segmenting the VLAN into multiple sub-VLANs. So I want to take control over who can speak with who in the same VLAN, which by default it's everybody can speak with everybody. But I don't want that to happen, so I'm going to take control by using private VLANs. Now, why do we need private VLANs? It's likewise a very old technology which was usually deployed in DMZ on DMZ switches. So DMZ stands for demilitarized zone, which means you're going to have in there your public services which are available from the internet. So DMZ, it's not a trusted zone. The LAN side is not the untrusted zone. The internet is going to be something in between. So we would deploy back in the days private VLANs also nowadays in the DMZ because this was aimed to segment network traffic within a VLAN in DMZ. Because what happens is that, assuming that, for example, looking at this diagram in here, like imagine that this is in here, this is my network. So upstream is going to be the internet, and we have like this DMZ in here. We imagine we have likewise a public subnet, and we have a lot of hosts in there. We're just going to be a web server. Server is going to be the FTP server, for example, the FTP server. And we have, I don't know, the DNS server, a lot of services available in there, DNS server, and all of them having public IP addresses. This is my setup, and of course they are connected to a list 1, a layer 2 switch in there, which is going to be the DMZ switch, a list 1 layer 2 switch. That's my DMZ, my publicly available service from the internet. So people from the internet are going to connect to the DNS server to query it, to the FTP server to download some data, to the web server to, access the web server for whatever. It's a commercial website or whatever that is. So usually in that DMZ, each server runs a dedicated service like we saw before, and there is no actual need for layer 2 communication between servers, between all of them. It may be the need that everybody speaks to the DNS server, for example, but pretty much the FTP server doesn't need to speak with the web server, or the web server doesn't need to speak with the SMTP server. So by default, because everybody can speak with everybody, if a server gets infected with malware, it can, by using private VLANs, it can no longer spread that malware to other servers in the same VLAN. Because if we don't deploy private VLANs, then in this use case, if an attacker manages to exploit a vulnerability in the DNS server and infect the DNS server, because everybody can speak with everybody in that VLAN, then that malware can actually potentially be let's say that malware can be also leaked to the FTP server or to the web server, or not even that. Just because the attacker is now on the DNS server, it means it can go and steal data from the FTP server or from the web server and then leak that data out of the network back to the attacker. So for this reason, I would want to do some kind of microsegmentation at the VLAN level so that there is no intercommunication, for example, between the DNS server and the FTP server. They don't have to speak with each other. So pretty much in this VLAN, nobody can speak with nobody else in that VLAN. The DNS server cannot speak with the FTP server. The FTP server cannot speak with the web server at layer 2, and the DNS server cannot speak with the web server because there's no need for that to happen. So if I implement some kind of microsegmentation in there, it means that once the DNS server got infected, then the attacker, once it's going to be present on that DNS server, cannot access anything else, any other server in that subnet. So his best chance is now to send some traffic in the inside network, but to do that it has to pass over to the security rules of the firewall, which that's not going to be clearly easy. So that was pretty much like one of the use cases of private VLANs, to do microsegmentation at the VLAN level to control who can speak with who in the same VLAN, so that if a server gets infected, it cannot spread to other servers, or if a server gets, let's say, owned by an attacker, the attacker cannot also connect to other servers in the same VLAN. Nowadays, we have like SGT, security group tagging, it's a much better technology to use for intra-VLAN traffic segmentation as opposed to private VLANs. But of course, if you don't have SGTs, private VLANs are still a, let's say, valid, useful technology. So private VLANs, to achieve that goal, to control who can speak with who in the same VLAN, it means I need that microsegmentation, which means I'm going to make use of two types of VLANs. I'm going to make use of one primary VLAN and multiple secondary or sub VLANs. Now, in general, the primary VLAN is the initial VLAN. Of course, you can do whatever you want, but in general, the primary VLAN is going to be the initial VLAN where all hosts were attached to, and they were able to communicate one to another. Now, and the secondary VLANs are going to be the new VLANs. It can be one or multiple, that's what I said is the new VLAN, because we can have one secondary VLAN or more than one secondary VLANs. So it's going to be the new VLAN where hosts will be attached to. And the secondary VLANs can be of type isolated or community. And as you're going to see, the name tells you exactly what it does, how it works. Now, once we have defined those VLANs, the primary and the secondary VLANs, then we have to configure the hosts to be members of the private VLAN configuration. So a switch port in a private VLAN configuration can be of three types. It can be a member of the isolated VLAN, a member of the community VLAN, or a member of the primary VLAN, which means is going to be named the promiscuous port. I'm going to explain a couple of what those terms means. They all make sense once you understand how it works. Now, the traffic flow is that members of the isolated VLAN can only communicate with the promiscuous port. So that's why they are called to be a member of the isolated VLAN. So two hosts in the isolated sub-VLAN, they cannot communicate in between. That's why that sub-VLAN is called isolated. They can only communicate with the promiscuous port. Members of the community VLAN can communicate in between, so two devices connected to the same community VLAN can communicate in between. That's why that's being called a community VLAN. It's a community, which means it has multiple members in the community, which means the members of the community can speak in between. And also members of the community VLAN can communicate with the promiscuous port, which means that usually the default gateway is going to be connected to the promiscuous port, because we want also members of the isolated VLAN and of the community VLAN to speak with the promiscuous port, which means usually that's going to be the default gateway connected to the promiscuous port, because we want everybody in that subnet to be able to exit the VLAN to access resources out of the VLAN. So usually the default gateway is going to be connected to a promiscuous port or any other resource that has to be reachable directly at layer 2 from both the isolated and the community VLAN. So now before we go to the further on, is like the following. If we make one very big switch in here, and we configure the primary VLAN, let's do this. Let me put this, that switch is too big. Let's do the following. Let's say that a primary VLAN is going to be primary VLAN. Let's say it's going to be 100. And then I'm going to have attached to that primary VLAN, we're going to see why it has to be attached to. Attached to that primary VLAN, we have one isolated VLAN. It's going to be red. Isolated VLAN. It's going to be VLAN 20. And one community VLAN. VLAN 30. And now let's put that big switch in there. We have a switch. And I'm going to put in here first of all the primary VLAN. So black is going to be VLAN 100. And then I'm going to put in here with red the isolated VLAN. And with green the community VLAN. And let's suppose that we have the following. We have host 1 who is connected attached to the isolated VLAN. It's VLAN 20. We have host 2 which is connected attached to the isolated VLAN, VLAN 20. Now I forgot to put something in here. Let's suppose that the subnet is going to be 10, 10, 10, let's say 10, 10, 10, 10, 10, the subnet. Session 24. And host 1 has an address of .1. Host 2 has an address of .2. So they are still in the same IP subnet. And then I have host 3 connected to the community VLAN of 30. So I have host 3 connected to the community VLAN of 30. So everything is connected to the same switch port in there, to the same switch. This blue is one big switch. And host 3 has an address of .3. And then we have like host 4 in here, connected to the community VLAN with .4. And we have a host 5 with an address of .5. And then we have connected to the primary VLAN, or it's going to be the promiscuous port, which the promiscuous port belongs to the primary VLAN. So connected to black, we have a router, which is the default gateway from that subnet. The default gateway is going to be, let's say, .100 and a DNS server. DNS server, which has .200 IP in that subnet. So following the rules which is stated before, it means that I'm going to use the color of orange. It means that host 1 and host 2 cannot speak in between. Actually, let me use the color of what color should I use? Because I'm left out of colors, I'm going to use this color. So host 1 and host 2 cannot speak in between because they are members of the isolated VLAN. And in one of the classes, the easier way I explain this is like you can look like the eyes. You can look like this. This is a prison, and the red people are the inmates where are like in the are the incarcerated or isolated because they have done bad things. And the green people, we have communities like, you know, community of the black people, of the white people, of the whatever. It's out there. So it makes sense that the bad guys which have been incarcerated, they cannot speak in between to another. They're isolated, each of them in its own cell. Now, people in the community VLAN, they can speak in between. They are outside. They have not done too many bad things. They are still in prison, but they can speak in between. So host 3 and host 5 can speak with another. Also, host 3 can speak with both host 4 and host 5. So those are people who have not been incarcerated in prison. They are in prison, but it's the community of whatever people it's in there. Of course, we could add another community. Like for example, if this would be another community, for example, to make even more sense. If this at the bottom left in here is going to be another community VLAN, because that can be the case. So we have another community VLAN which was VLAN, let's say 40. So it's like we have two communities, the communities of black people, the community of white people in prison. So clearly and we have multiple hosts in here. We have also host 6 connected. Host 6 connected in there. So in this use case, people in community 30, they can speak in between. That's like the white community of people. They can speak in between because they are in the same community. People in the orange community, they can speak in between because they are in the same community. But between communities, they don't speak to another. So like host 3 cannot speak with host 4 because it's different communities. And we know, like in prison, the black people hate white people, the white people hate black people, or whatever. But of course, everybody everybody in the community VLANs or in the isolated VLANs, all of them can speak with the promiscuous port. Of course, if the promiscuous port so chooses to. Also, all of them can speak with both the default gateway and the DNS server. Where if you follow up the prison example, that's going to be like the guard, right? So the guards are going to speak with all inmates, of course, if they please to, right? And in production network, as I stated, usually the default gateway is going to be a service like a DNS server, which has to be reachable by everybody in that configuration, or the default gateway so that everybody can exit the VLAN to be able to route packets out of the VLAN. Okay, now if VTP version 2 is used configuration-wise, we have to set the VTP mode to transparent for a specific reason, because VTP version 2 cannot advertise private VLAN configuration. If VTP version 3 is used, you can run VTP in which mode you want. Client, transparent, server is going to work, because VTP version 3 can advertise private VLAN configuration. Then we configure, the next step is going to be to configure secondary VLANs, name them isolated or community. Then we configure the primary VLAN and we bind the secondary VLANs to the primary VLAN. Why do we do that? Because we can have multiple such associations. We can have, for example, isolated VLAN of 10 and community of 20 associated with the primary of 100. And isolated VLAN of 90 and community of 120 associated to primary of 200. So just configuring the type of VLANs is not enough, because you can have multiple such associations. It means you have to bind the secondary VLANs to the primary VLAN. And of course, the last step is going to be to configure the layer 2 ports as private VLAN ports of type isolated, community, and promiscuous. And again, the name makes sense. So isolated ports cannot speak in between. Community ports can speak in between, and both of them can speak with the promiscuous port, because by the name promiscuous means it listens to everybody, right? It's promiscuous. Verification wise, we verify private VLAN configuration and port membership with show VLAN private VLAN, and we also then verify the private VLAN port type which show interfaces, the interface number, and switch port. Now, private VLANs, of course, because in the DMZ you can have multiple switches, private VLAN configuration may span across multiple switches. That's a valid design and it works. So we have another variation of private VLAN which is called private VLAN edge, which is a variation of private VLANs which is simpler but less feature rich. It's also known as protected port. And also, traffic segmentation with private VLAN edge cannot span across multiple switches, while with regular private VLANs, it can span across multiple switches. So the limitation of private VLAN edge is that configuration to limit who can speak with who in the VLAN it's contained in one switch, that policy, and it's less feature rich because what you do, you just define the layer 2 ports as protected ports, and the rule is that the switch is going to block all direct layer 2 traffic between protected ports. So it's simpler, easy configuration, less feature rich. It's simple, all traffic is blocked between all protected ports, and it's less feature rich also because it doesn't span across switches. So like if you look at our diagram in here, if we would have another device connected to the switch, like PCB, and we go on switch 1, and we make this port and this port, both of them to be protected, so private VLAN edge, it means that PCA and router 1 cannot speak with each other directly. Traffic is blocked. So traffic between protected ports is blocked. But traffic between protected ports and unprotected ports, which is default ports, can work. So it means that PCA and PCB can communicate because it's between a protected port and a regular port. And traffic between router 1 and PCB can work because it's likewise between a protected port and a regular port. So that is private VLAN edge. Configuration wise, we just configure the layer 2 ports as protected. Verification wise, we just state, we verify if the port is defined as protected with show interfaces, the interface number, switch port. So both private VLAN and private VLAN edge are going to be influencing, are going to control who can speak with who in the same VLAN. So they do micro segmentation at the VLAN level, but in different ways.